Hello Year 10, I hope that you are doing well and keeping up with all of the work. Today we are going on with directions and bearings. So we're going to be finding bearings. Bearings are used to communicate the direction of one object from another. There are two systems that are used for describing bearings, and we're going to look at both of them today. So the first one we want to look at is true bearings. True bearings are always measured in a clockwise direction, starting from the north, which we call 0 degrees T. T standing for true bearing. Okay, so the measurements always start from the top up here, which is 0. We call this 0 degrees. And we go clockwise around to whatever direction we want to head off in, imagining that you are standing here at the center and it's the angle from there that you want to walk in. Okay, so I have drawn a couple of lines on here for us to practice true bearings. We've got the 360-degree protractor behind to help us. So let's start with the green one. If I want to know the true bearing of that green line, we start at the 0, and I want to know how many degrees all the way around to that green line. Well, using the protractor, that line is coming round to 210 degrees. So that's it. That's all we have to do. As a true bearing, that is 210 degrees, and we put a capital T after that, saying that that is a true bearing. Okay, let's do the blue line. For the blue line, the true bearing, again, we always start from the top up here at 0 degrees, and we always go clockwise. Don't go backwards. Clockwise all the way around to the blue line, which is going to be, using the protractor, 320 degrees T. Okay, that seems pretty straightforward. Let's have a look at the second type. We now want to have a look at compass bearings. Compass bearings use the north and the south as a reference point to start with. So compass bearings are measured first relative to the north or the south, and then relative to the east, how many degrees towards the east or to the west. Okay, so again, if I come back to my green line here, my green line is heading towards, it's not directly south, but it's definitely heading in a southerly direction. Okay, so we would start by describing that as being south. Oops. Then we want to know from the south, because that's what I've started with, how many degrees we are traveling towards and we're traveling towards the west. Okay, so don't say 210 degrees. That's the whole angle from the north up there, remember? So that is just 10, 20, 30 degrees, that little angle in there. So it's south, 30 degrees towards the west side. Okay, for our blue line, this time we are heading towards the north side of things up here. So it would start with north, and it's how many degrees from the north towards that blue line. So that's 10, 20, 30, 40 degrees towards the west again. So they're the two types, true bearings and compass bearings. The thing is, you're not always going to have that protractor behind to help you with these questions. Most of the time, your questions are going to look like this little one I've drawn over here in green. You're just going to have your compass with your north, south, east, west on it, and you're going to have one little line coming out of it somewhere with an angle on it, like I've got one there at 10 degrees. Okay, so if I wanted to find the, let's start with the true bearing. If I want to find the true bearing of this line that I've drawn on this one down here, remember you start from the north, and I want to know how many degrees around till I get to that line. So you don't have the protractor, so you'll need to know it's 90 degrees to there. If we had to keep going, it would be 180, 270, and all the way back to 360 if we went all the way around. Okay, but we want to travel 90 plus that extra 10 would make it 100 degrees T. Okay, then to do a true bearing, a compass bearing, sorry, we then say, is it closer to the North Pole or to the South Pole? So north is up the top, south down the bottom. This one is heading generally towards the south. So it's going to start with south. How many degrees is it from the South Pole? Well, it's not the 10 degrees because that one's not attached to the south arm there. That would be an 80-degree angle in there because it's a right angle, remember? So it'd be south, 80 degrees towards the east. All right, now that is an explanation of true bearings and compass bearings. However, it does say down the bottom here that in the majority of cases, we will be using true bearings most of the time. Okay, so that is the main one to focus on. So on the next page, these are the examples. Give the true bearing for each of the following points from the origin, which is called O. So we have a whole bunch of little lines coming out of our compass there. We're going to do them in alphabetical order. So it says down here, find the bearing of A from O. Okay, so here is A. This is the one we want to find the bearing of first. True bearings this is. So true bearings are always measured from the north around to the arm. I need that angle there. Now I don't have an angle for that one at the moment, but I do know that I have this 30 degrees here. So if I went 90 minus 30 degrees, that would make this 60 degrees in here. So that means my true bearing is 60 degrees T. Now technically for a true bearing, you'll often see a 0 written in front of that because we should have 3 digits for a true bearing. Okay, next one. Part B, we want the bearing of B from O. Okay, so we're looking at B this time. So we need the angle all the way from the top, all the way around to that arm. So try to look for right angles. From the north around to the east, there's 90 degrees. Then we need to add on this extra little part here, which we're told is 45. So it's going to be 90 plus the 45, which is going to be 135 degrees T. All right, let's get rid of all my little working lines on there so we can do the next one. Now we want to do the bearing of C over here. So from the north all the way around. So we have 90 degrees to there, 180 degrees to the south, and then we need to go this bit extra around here. Okay, now because of this 20, 90 minus 20 means that this would be 70. So if I go 180 plus that 70, it would give me the true bearing. 180 plus the 70 makes 250 degrees T. One more to go. This time we want the bearing of D from O. So, like we always do, from the top all the way around to there is what the angle that we want. So we have 90 degrees, 180 degrees, 270 degrees to get to there, plus this extra 75. So it's 270 plus the 75 is equal to 345 degrees T. All right, good. Now, there's actually more to this topic, though. We actually want to use this now with our trigonometry to help us with some wordy questions. So, we have a ship sails 12 kilometers east, then on a bearing of 150 degrees for 15 kilometers. So you should always, always, always draw a diagram to show what is going on. So first of all, our ship travels 12 kilometers east. Now, if you need to, you can draw yourself up a little compass up here, north, south, east, west, just to get all your directions that you need. So east, 12 kilometers east. I'm going to draw a line going that way for 12 kilometers. All right, then it travels on a bearing of 150 degrees for 15 kilometers. Now, a bearing is not quite so easy to get right without showing a compass on there. So what I'm going to do, I'm going to use a different color to do some compass arms at that point. So I'm here at the end of my first arrow, and here's my compass, because I now need to measure 150 degrees, not accurately, but just approximately. So remember, to this arm out here, from the top around to that first arm, that would be 90 degrees. 180 would be going down, so we don't want to go that far. So 150 would be coming somewhere out this way. And we want to do that for 15 kilometers. Now, your lines don't have to be accurate in length, but usually I like to know that the longer one looks longer. So my 15 kilometer line should look a little bit longer than my 12 kilometer line. Okay, so there it is. I'm also going to mark on there the angle that we've done, which is 150 degrees. You need to make sure that you do. That's going to be important for our calculations. So, part A says, how far south is the ship from its starting point? Well, it started here, and this is where it ended up. How far south is it? Now, south is this distance here. So north is at the top, south is going down. So what we do is we go straight down and straight across to our finishing point, and that makes us a right angle triangle. Okay, and we are trying to find this side here. We want to know how far south the ship is, and that is the line that measures the south direction. Okay, so we have a right angle triangle. We know what we're trying to find. We have one side in our triangle, but the only angle we have is this 150 degrees. So we would like to find an angle inside of our triangle. So knowing that it's 180 degrees when you're heading south, if I do 180 minus 150, that tells me that this angle in here is 30 degrees. Okay, so now I'm ready to do SOHCAHTOA. I have got the adjacent side and the hypotenuse, so we're going to be using cos. So for part A, we're using cos theta equals adjacent over hypotenuse. That's our formula. Subbing into that formula, we have cos 30 is our angle. The adjacent, I have called it little a, over the hypotenuse, which is 15. Then to get the a by itself, because the a is on the top, I want to multiply the 15 across to the other side, which will make 15 times by cos 30. And we type that in our calculator. Okay, and we get, just looking to see if we're told where to round, nope. So we're going to do 2 decimal places here. 12.99, and the units are kilometers, and I'm just going to put 2 dp after that because that's where I chose to round it. Now part B. How far east is the ship from its starting point? Okay, so this is my ship down here at the bottom, remember, down here. Okay, so I want to know how far east it is now. It started here and it finished here. I need to know how far east it has gone. I know it went 12 kilometers to start with, but I also need to find this part here because that is also traveling in an easterly direction. So let's find that side B that I've labeled there. To do that using the same triangle as before, I'm going to be using the opposite side and the hypotenuse. So that's sine. Sine theta equals opposite over hypotenuse. Substituting in, we have sine 30 equals, the opposite is b, the hypotenuse is 15. Times the 15 across, and we get b equals 15 times sine 30 in the calculator. Okay, so 7.5 kilometers. Now that's not the whole easterly direction. Don't forget to go back and write down the total for this one. There was 2 parts. The total distance east is equal to the 12 kilometers that we started out with in the easterly direction, plus that extra 7.5 down here, which we labeled B. That altogether is 19.5 kilometers that they have traveled east. Okay, so you need to start on exercise 7D. You will also get another lesson on this.